Hi, I'm Bob Tabor with www.learnvisualstudio.net, where I teach beginners the skills they need to get their first software development job building Windows and web apps to the world's best companies as quickly as possible. So we haven't spent much time talking about scope with regards to variables, so I want to more fully explain that concept and then use that as a launching pad to explain the keywords private and public that you've seen several times in relation to writing methods inside of classes. Now, before we jump into that topic, let's talk about variable scope. Let me start by saying that whenever you declare a variable in a code block, that variable is only alive for the life of that code block, meaning that when that code block is finished executing, the variable that was defined inside of that code block is no longer accessible, and its values are disposed of by the .NET Framework runtime. So let's take a look at how that applies to common code blocks that we've worked with up until this point. Let's begin by creating a new project called Understanding Scope. So while I'm just going to start with talking about like strings or integers or something along those lines, I guess integers for the most part, these concepts that we talk about will also apply to object variables, the variables that hold references to new instances of classes, all right? So just keep that in mind, and we'll elaborate on that a little bit later. But let me start off by just doing a for. In fact, I'm going to go ahead and go for I equals 1 to 10. And console.writeLine the value of I, and console.readLine. Great. And as we would expect, this will just print out 1 to 10. All right. Now, what if we were to try this? Console.writeLine I. Well, you can see, first of all, as I try to type in the letter I, I'm fighting IntelliSense. It doesn't let me just type in the letter I. It wants me to do int or int16 or something like that, right? So if I just hit escape on IntelliSense and move my mouse cursor off, I see a blue squiggly line, and I see a little red X icon, and it's asking me if I want to generate a stub for I in module 1, or if I want to generate a field for I. And so here we see that the result of trying to access a variable that's declared inside of this code block will not be accessible outside of that code block here in the remainder of my submain. All right? So I'm going to comment this out. I'm going to try another little test here. Let's go here, and we'll do a dim j as string equals empty string. And then inside here, I'll go j equals I dot toString, and here I'll do console.writeLine the value of j, and I'll actually do this j equals, and then I'll use the ampersand and j like so. All right, just another way to write a string using concatenation as opposed to like the replacement syntax that we've been using up until this point. All right, so we run the application, and we can see that at the very end of the iteration that j equals 10, because that was the last time j was set. If we look at our code, j was set inside of the for loop. However, it was declared outside of the for loop, kind of in the same area here as the rest of my submain. Let's take this one step further, and we will try doing this. We'll create a private field, private k as string, and we'll set k equals to I dot toString, and we'll try to access k like so. K equals. All right, will this work? Will we be able to retrieve the value of k and display it? And we can. And why is that? Because even though k was declared outside of the scope of submain, it's within the scope of module 1. So k is available inside submain and would be available even outside of submain in any additional helper methods that we wanted to create. And we'll do that in just a moment. So just to reinforce this idea, inside of the for loop, let's try to do this. If I equals 10, then dim L as string equals I dot toString. And then we'll attempt to read out console.writeLine L equals, and then we'll ampersand L. And you can see that I'm already fighting IntelliSense. It doesn't recognize the variable L. It wants me to type the letter long. I'll hit escape and I'll try to move off of that line of code with my arrows, and I see the blue squiggly line. So L is not available. Why? Because it was created inside of this if statement. Is it even available outside of that if statement? Let's take this line of code and let's attempt to move it up into the for loop like so. And I still see the blue squiggly line because once again, it's not usable outside of the scope in which it was declared. It was defined inside of this code block, and yet we're trying to access it from the outer code block, and that's not possible, all right? The only thing that we could do in this case is to move that into the same code block like so, at which point it should work. And it does. You can see L equals 10, okay? So let's take this idea one step further. I said before with regards to K that it should be accessible not only to submain, but to anything else kind of at that same module level. So if I were to do this, private sub helper, lowercase h in helper method, and console.writeLine, and we'll set K from helper method equals, and then K. Does this work? Well, we have to call it actually. So let's call helper method right here, like so, and now we can see that K is accessible from within the helper method. It is set equal to 10. All right, so hopefully if you've had any confusion or misconceptions about variable scope, we've cleared it up in this little example. Again, you can only access variables or object variables or whatever the case might be inside of a certain scope. The scope has to be within the declaration of the given variable. So in this case, with the private K, a string defined at the module level, it's accessible to anything that's a sibling to where it was defined, or any child of the module 1. As we've declared I inside of this for next statement, because of its declaration right here, we can only use it inside of the for next statement. We can't use it outside. As for J, we're able to use it inside of the for loop and outside of the for loop because we defined it at the main, sub-main level. All right? So hopefully that makes sense. And let's continue on from there. So in the methods that we've written in previous lessons in classes, we've always started with the words either public or private. And so let me just add a class. And again, we'll work with car, like so. And I'll paste in from my clipboard. We've used the word public for the class name, public for the property name, and so on. So these are called accessibility modifiers, or they're also known as visibility modifiers. And they're used to implement the tenet of object-oriented programming called encapsulation that we talked about previously when we created the long form of the property and showed the private field that actually stores the value, and we use the get and the set of the property to allow access or restrict access to that hidden private field value. All right. So in a nutshell, classes should be black boxes. So when I think of a black box and when I think of an example for this, I think about the old style television sets like when I was a kid. When I was growing up and when I was a kid, we had a simple television set. It had an on-off button and it had 2 dials, one for volume and one for the channel, and that was it. And so if you wanted to actually change the channel, you had to get up from your chair, you had to change the channel on the television set, and that's what kids were for, right? So it also maybe on the back had a place where you could attach an antenna. and an electrical cord with a plug on the end, and that was all. Everything else about the television was self-contained. As a kid, I was fascinated once or twice when my dad would take the back off the television set to replace a tube. I still don't know what he was doing inside of there. It seems like a magical device with all these tubes and wires running every which direction. All I needed to know how to operate the television was through its public interface, the dials, the button, the power cord in the very back. And frankly, to use the TV, that's all I needed. The same should be true of classes that we create. All the important behind-the-scenes functionality should be encapsulated behind public methods and public properties. That's really the interface from a programmatic standpoint that other code should use to interact with our class. They should know about how our class is implemented under the hood. All right. The class might have private properties. It might have private fields, in other words, as well as private methods used to enable all the magic that goes inside of the class. But the consumer of the class shouldn't have to know anything about the inner workings of the class in order to work with it, to operate it. All right. So in a nutshell, private means that the method can be called by any other method inside of the class, but not outside of the class. So you use the term private helper method just like we learned about several lessons ago. So let's create a private helper method. Private function helper method as string, and we'll just return howdy partner. All right. And then we create public methods, whether it be a sub or a function. Do something. And inside of there, we can do console.writeLine, and we can call the private helper methods. But the only way we can get to the private helper method and any other code that might be contained within is to use it through any of the public properties or public methods that have been declared. So if we were to come over to here and right above the console.readLine, we were to go dim my car as new car and my car dot, and you can see all we can get to are the 4 properties that were made public and then this public do something. And I could console.writeLine, well, I don't even need to do that, do I? I can just call it like it is, like so. And you can see we get howdy partner. Now, where did that come from? How was that implemented? From all I know as the consumer of the car class, the do something method works some magic internally and returns the value. And that's all I care about. I don't care about how it's implemented internally. All right, so that's the notion of encapsulation. Now, let me just say this. In a real project, I would never do this. I would never actually print anything out to screen. That's the responsibility of presentation code, not, in this case, the car code, the domain class. And I realize you have absolutely no idea what I'm talking about. Just never do that. I explained the reasons for this in a series on application architecture on my own website, www.learnvisualstudio.net. And so that's kind of an advanced topic. But just know that you probably should never call console.writeLine from a class. Okay. Okay, so in a sense, the consumer of the car class has no idea that the helper method even exists. All it knows is that to accomplish its task, it needs to call do something. Obviously, now we as developers, we can go into this car.vb file and we say, oh, I see how they did it. All right, but that's not what we're talking about here. If we became, in a sense, the sub-main, and we looked at it from its perspective, we wouldn't be able to see how do something worked internally. Now, admittedly, this is an extremely mundane example. Its only real value is to illustrate the notion of encapsulation and hiding the implementation while exposing a public interface, and that's all I really intend for that to be. All right. So the next thing I want to do is talk about the naming convention that I used, and we spoke about this a couple of lessons ago. I just want to reinforce it now. Whenever something is public, whenever we define something as public, whether it be a property or a name of a method, it should start off with a capital letter and then use camel casing from that point on. Whenever something is private, it should start off with a lowercase letter and then use camel casing from that point on. And this is just a naming convention. Are you free to break the naming convention? Absolutely, knock yourself out. You don't have to pay attention to this at all, but you might do so at your own peril. Other programmers are going to look at your code and they're going to say, what were you thinking, man? And so it's just an easy way to identify the accessibility of a given method or property field by looking at its name and deriving from that whether this is a private or a public method, a private field or a public property. All right. The same would be true for variables and things of that nature. Notice that all the variables that I use here in my example in what I would call the local scope, local to submain, I use all lowercase letters, even this private K here at the top. Why? Because again, they're either private and local to submain and cannot be seen outside of submain, or they're private to the module and cannot be seen outside of the module in the case of K. All right. So what's the purpose of this pithy little example that we've gone through? I really want you to be thinking about primarily using this information with regard to the .NET Framework class library. However, if you ever were to build your own custom classes, you should strive to expose public methods that give a simple, straightforward, obvious usage while keeping other helper methods and functionality privately tucked away and unavailable from prying eyes. You don't want developers fiddling around with your innards of your classes and potentially using your class. You want to give them a way to use the class properly through public methods and public properties through the methods that you design. All right. This also removes ambiguity and it makes its usage obvious and clear. So in the .NET Framework class library, methods and properties are exposed using the keyword public. They might also use private methods and fields, but you'd never know. They may use other types of accessibility modifiers, such as protected, which is a third accessibility modifier we didn't talk about. Basically, a protected method in a base class is visible to its derived classes, but no other classes. And private methods in a base class cannot be seen by its derived classes, so that's why you needed the notion of protected, so that you can make those helper methods available to any of the derived classes. So as you can see, the accessibility modifiers like public, private, and now protected provide different levels of visibility depending on what the author of the class deems necessary. So just be aware of this. If you can't access something that you think you should be able to access, it might be because that particular method is hidden or by private or protected on purpose. All right? So in this lesson, we talked about variable scope, how variables have a lifetime, I suppose you could say, based on the code block in which they're defined. When the current code block is part of the current scope of execution at runtime, then the variable will be available. When the current scope of execution no longer involves the code block, so in this case, in the for statement, when we've moved out our scope of execution no longer involves the for and we've moved past it, then the variables that are declared inside, like the I variable, for example, will no longer be available. And we also talked about accessibility modifiers like public, private, and then finally protected, and how that might impact the way in which we use the .NET Framework class library, and perhaps even someday whenever we sit down to create our own class libraries, making sure to hide the implementation details and the private helper methods behind public method interfaces. All right? Hope you got that. You're doing great. We'll see you in the next lesson. Thank you.